So here's video 1.6, and man, if you came in the other day and I gave you a practice worksheet, I have changed that practice worksheet for all you people out there in video land. So you can come get a new practice worksheet from me, or you can copy this down on your own. But here's what we got going on. I got some real simple ones to start out with, at least in my opinion. We'll grow to get better at them. But they ask us to find the measure of the missing angle. And here's something that on this worksheet I wish I would have had. Your homework's going to have it this way, but it won't be on this one. Do you see this 117 right there, guys? And they're asking me to find 1. Here is the secret to how this class works. We need to learn to ask ourselves, what kind of angles are these? And here, I don't care about acute, right, obtuse, or any of that stuff. I care about, are they linear pair or are they vertical angles? What do you think? Are they right across from each other in the X, or are they like side by side touching each other forming a line? What do you think? Linear pair or vertical angles? Those are vertical angles. Do we remember what's true about them? If this one's 117, how much should that one be? The same, right? So here's what we'll learn. That putting info in the picture is going to save our life. You know, geometry is hard if you can't see it, right? So we're going to put the info in the picture, and we're going to answer the question, 117 degrees. But here's the part that a lot of newbies in this class don't like, justifying our answer. And all that is a fancy word for, can you tell me why? Like, can you prove it to me? And coming up next chapter, we're going to do some real big boy and big girl proofs, but we're easing our way into it here in the next couple of days. But here's what we do. If you can answer this question, we'll be in good shape. What kind of angles were those? Say vertical angles. They were vertical angles. There's a theorem out there that explains that they should measure the same. You've probably heard of one theorem in your life so far, the Pythagorean theorem. Do you remember that guy? Like a squared plus b squared equals c squared in a right triangle. There's all kinds of theorems. Theorems are excellent evidence that the math lawyers, that's you guys, get to use to prove stuff to the math judge. That's me. Like, the lawyers have to have the right evidence. So the reason why those vertical angles are the same, right with me and we'll get better as we go along, is the vertical. You got to spell that word right for me. V-E-R-T-I-C-A-L. Vertical. Got to spell that out. Then I'm going to use an abbreviation here. See if you know what this means. What does that symbol mean right there? Angle. And then the word theorem, we also abbreviate that, just THM. So it's the vertical angle theorem. To prove stuff in math, one thing you could use for evidence is a theorem, right? So the vertical angle theorem, it's so simple. If you got vertical angles, they measure the same amount, right? This one was 117, the other one's got to be 117. And we will get better at that as we keep practicing it. Cool? So, number 2, here's the magic question. This is a 40. This is the angle 2 they want us to find. If your brain can do this, I will guarantee you, you will be successful. You ask yourself, what kind of angles are these? Your 2 options are linear pair or vertical angles. Discuss. It's cool if you're still not sure. We'll get better at that. But the 40 and the 2, are they linear pair or vertical angles? Yes, and we do need to say the word pair after it, right? Linear pair. Are we okay with that? They are 2 angles. If I highlight them, do they touch each other? Yes or no? And do they form a line? What do you know about them? They're not the same. They add up to be how much? 180. So if this one's 40, you can use a calculator if you need to. How much has the other one got to be? We'll put it in the picture, and we'll put it in the blank. 140 degrees. And here's why. It's not the vertical angle theorem, because those aren't vertical angles. It's something called the linear pair theorem that says if you have 2 angles that are a linear pair, they got to add up to be 180, right? So 3 words. Linear. You do have to have the word pair, and then you can abbreviate theorem, THM. You can abbreviate the theorem, THM. Linear pair theorem. And to be quite honest with you, that's the basis of what we're doing today. We're going to throw a couple twists in there, but we're just, are they linear pair or are they vertical angles? So could you do that on this one? Let your brain do the work first. What kind of angles are we talking about on number 3? Linear pair or vertical angles? What do you got? These are vertical angles. If this is 130, what does this one have to be? 130 degrees. And the question you're going to hate is me going, why? Why do vertical angles have to be the same? 3 words, baby. Vertical angle theorem, right? Just don't abbreviate the word vertical. Vertical angle theorem. But baby, those are way too easy. We had to do no math to really figure that out. We just had to recognize. So let's get a little more interesting. Do you see this 120 right here? And do you see this 2x minus 10? Could you please talk with your table? What kind of angles are those? Vertical angles are across from each other in the x. Linear pairs are right next to each other, side by side. What do you think? They are? Vertical angles. What's true about them? Yes, I totally get they're across from each other. Do they add together to equal 180, or are they the same? Same? So here you go. This is the part you might not like. I'm going to make them the same. 120 equals 2x minus 10. So here's what we got to do. I need patience from you. Go ahead. Sorry, question? Okay. We need to solve this for x, and oh no, algebra is coming back. So I don't know your algebra ability. I'm going to treat you like a rookie right now, and you're going to show me what we can understand and can't understand. But how do you feel about this dude right here? Sorry, grabbed the wrong button. Is the term with the x in it? Is there anything being added or subtracted to that guy that we need to move over first? You see the minus 10? How do you get rid of a minus 10? Add 10 to both sides. So we're going to add 10 to both sides. 120 plus 10 is 130. And here's what I care about. We have to show this work very similar to the way I'm going to. I will show you some steps you don't have to show in a minute, but I want to gauge your algebra ability. Sound all right? So you got to bring the 130 down. The equal sign still comes down. The 2x is still there, and note the minus 10 and the plus 10 add up to be nothing, right? X is not all by itself. There is a times 2 in front of it. How do you get rid of times 2? You are welcome to use a calculator by dividing it by 2, but we have to finish it. X equals 65. Are you with me? Or 65 equals x, right? But you see how I have an equal sign coming down? I kept it all nice and lined up, you know, all that good stuff. So we found that. Why? What kind of angles were they? Linear pair or vertical angles? So why did I set them the same? 3 words. Vertical angle theorem. The vertical angle theorem says if you have 2 angles that are vertical angles, they should measure the same amount. But mathematicians don't want to write all that out every time. You just write vertical angle theorem. Feel okay with what I did there? I had vertical angles. I set them equal to each other. So now I'm going to really make you feel silly for a moment. Yes, sir? The answer is yes. We have to show all that work. The one thing that you might not have to show is right here, the plus 10 to both sides. I don't know what our algebra ability is. I call those baby steps, you know. I didn't even show divide by 2, but this is something that we are trying to train you on. Next year, you will be a lost little puppy if you don't know how to do algebra. Does that make sense? So instead of throwing you into the deep end in an Algebra 2 class and you've never shown algebra work before, we're going to practice it the right way. Sound cool? I'm glad you asked. Right? So good stuff. Any other questions before we move on? Awesome. Here's the part that I'm going to be honest with you about. You will find this pretty easy when I'm talking you through it. And as soon as I stop talking you through it and I give you the homework or the tests that we have, you go, I don't know what to do. That is a normal thing. So here's what I want to train you on. The very first thing that you need to do is learn to talk yourself through a problem. All right? And here's the first question that your brain needs to do. Obviously not out loud, but in your head. What kind of angles are these? Can you answer that with your neighbor? What kind of angles are those? What kind of angles are these? 2 choices, vertical angles or linear pair. Thoughts? Linear pair, right? Should they be the same or should they add up to equal 180? Okay, I'm going to do this first one the long way. And you just watch my first move and see if we can handle skipping it. I'm going to take this, right? You don't need to write this down. Just watch. 2x. And I'm going to take this, and I'm going to add them together. And didn't you say I need to set that equal to 180, right? I was supposed to add those together and make it equal 180. But why did I say you don't need to write all this down? Because we are not algebra rookies. We have had an entire year of it. We will get better at it. But what do you see about this 2x and this 4x? Are they on the same side of the equal sign, or are they on different sides? Can't we just, like, combine those right away? Like, would that be cool if I said add these together? You'd say, okay, I'll add the 2x and the 4x. What's 2x plus 4x? So I think we'll start here, if you want to, 6x. And then I'd add up all what's called constants. Like the 108 is a constant because it doesn't have a variable with it. This has no constants with it, so it's just plus the 108. And that should equal 180. Why did I add them together and set it equal to 180? Because these are a linear pair. And that's the linear pair theorem, which we'll justify in a moment. But now, let's finish our algebra. Let's solve this for x. How do you get rid of this plus 108? And here's where I want to turn you loose on you know your algebra ability better than I do, right? If you do not need to show this minus 108, minus 108, I'm not going to make you put that. Does that make sense? But you do have to subtract 108 from both sides. Rock on? So the 6x has to come down. The equal sign has to be there, and you could punch in. We all need a calculator, myself included. 180, take away 108. No shame in punching that in. I think it's 72. Is that right? Cool. What's my move now to solve for x? Divide by 6, right? So I'll punch that in. 72 divided by 6. I got 12 back. X equals 12. Again, I don't care if you put this divide by 6, divide by 6. You know if you need that or don't need that. But everything in green needs to be required for work shown. Is that okay? Let's justify it. What kind of angles were they? Linear pair of vertical angles. Linear pair, and throw a theorem after it. THM. The linear pair theorem says if you got two angles that are a linear pair, they better add up to be 180 degrees. We're almost there, baby. Feeling all right so far? We're getting better. We're just going to keep doing it. It's like that's how you get better at something. Just keep doing it, keep doing it, keep doing it. So first thing I want to do on number 6 is scratch that out. I want to modify this question. We're going to scratch that out. We're going to scratch that out. And could you tell your neighbor what the first question your brain should come across when doing this? So we scratched that out. We scratched that out. What should you ask yourself when attempting these problems? Talk to your neighbors. And it's going to get deeper than this. It's not, are they linear pair of vertical angles? I appreciate it. It's what kind of angles are they? We'll also learn about corresponding angles, alternate interior angles, same side interior angles. So we have a lot more coming. It's what kind of angles are these? Today, it's either linear pair or vertical angles. What kind of angles are they? Vertical angles. What's true about them? Equal or add up to 180? So let's set them equal to each other. Solve for x. Let me help you. I want to not let you do two steps at once. We're not ready for that. I don't care how good your algebra ability is. We're not going to do two things at once. Aren't there x's on one side, x's on the other, numbers on one side, numbers on the other? So let's move the x's first. Who's the smaller amount of x's, 2x or 3x? Let's move that over. I don't care if you show these baby steps. I'm going to show them for the people's benefit. But we're only going to move the x's. Those go away. 25 comes down. Equals comes down. What is 3x? Take away 2x. 1x. Minus 10 still there. Now, to solve for x, oh man, how do you get a minus 10 over to the other side? Yeah, add 10 to both sides. But what I was trying to say is I do not want you to subtract 2x and add 10 all in one move, right? You've got two separate moves there. Move the 2x, bring stuff down, add the 10 over. So 35 equals x. See if you can justify that knowing that those were vertical angles, right? Those were vertical angles. What's your justification behind that? Vertical angle what? Theorem. Would you like to see how easy that is to get wrong? Here's what many people will have on their test. What's wrong with that? Are they called vertical pairs? They're called what? Vertical angles. Vertical angle theorem. Doing all right? Cool. I will help you more later if you need help with that. This is different. Are we down with the fact that these are not vertical angles? They're not across from each other in the x. They're not a linear pair either, because this thing right here, if I would highlight it, doesn't form a line. Are you with me on that? Other side. Don't do that many at a time. Don't do that many at a time. Only about 10 at a time. This does not form a line. Does that sound all right? So it's not a linear pair. But man, you see those red things right there? Those are called arc marks, right? What do they mean to you? What do they mean? Both angles are the same. Now watch this. See this dude right here? He's a special guy. Starts with a B. Take a wild guess with your table group of what that blue thing is to that big orange angle. Starts with a B. It's a what? Bisector. That's what those arc marks mean. This blue thing totally bisected that guy. So shouldn't these be the same, right? Guess what we'll do with these expressions? We'll take 2x plus 35 and tell me a cool symbol that means the same. Equals 5x minus 22. Could you in your table solve that for x? I set those the same because that's what those arc marks mean. They're the same, right? So solve for x. If you mess up, we'll fix it. It's no big deal. We'll fix it. Move the 2x first is what I would do. Move the 2x first. Minus 2x minus 2x. 35 equals 3x minus 22. Add 22 to both sides. Is that 57? Is that right? And then, of course, we still got to finish by dividing by 3. 57 divided by 3. Feel free to punch that in. What did we get? X was 19. Oh, man. Get ready for this. You're actually going to like it. Why? Why did we set those equal? And we can't do because I am very serious about this. If you were in court and you were a lawyer and you went up to the judge and they said, did you kill that guy? And they said, no. Why not? Because you would be in prison immediately. And it's not a joke. Do you understand me? This is not a joke. This is the point of this class. If it was going away, I would make a joke of it. This is what we're going to do all year long, is prove stuff. And if we don't start off on the right foot, you will hate this class more than you hate it right now. So the question is, why? Is it the vertical angle theorem? Were those vertical angles? Nope. Is it the linear pair theorem? Was that a linear pair? So do you see what I'm doing? Process of elimination, right? It's like it couldn't be those, right? Tell me what that blue thing was again. Started with a B. Isn't that a bisector? What does it mean? Does it mean that those should be the same, right? That's exactly why we did it, because that's what bisector means. And I don't know if you've ever been told this, the meaning of a word is called the definition, right? So the reason behind this is the definition. You can abbreviate that as DEF, definition. What was the word that the blue thing was? Definition of bisector, or bisect. Definition of bisect is totally why that happened. And we're going to use definitions more than anything. How many vocab words have we had so far, right? Yes, ma'am. I would like it because it kind of makes sense. You know, I'm glad that you asked. If you didn't put it, I probably wouldn't mark you wrong, but it's the definition of bisect, you know. So good question. So she asked if we needed to put the word of. Let's try the next one. We're going to do this in phases. Could you do this for me, because I didn't give you much space. Do you see this like area that I'm highlighting in the rectangular region right here? Leave that empty. We need to do some algebra in that spot. We're going to draw a picture also. Can you draw B as the midpoint of segment AC? You need a straight edge. I don't care how much you measure it, but don't make it very big. Leave yourself room. Draw B as the midpoint of segment AC. How do you get started? Draw segment AC first. So use your straight edge. Draw segment AC. Who are the endpoints of segment AC? A and C. And then they want B to be the midpoint of it. So I don't need you to measure it, right? We definitely want to try to put B somewhere close to the middle, but it doesn't have to be perfect. But what we're going to do is have the math way to like know it was in the middle. There's some markings that I could do. Do you guys, first, before I call on you, talk with your table. How do I mark it to where like those two are the same? What did you think? Tick marks? You guys feel okay with that? The cool thing is, I know you want to say tick marks. The bad thing is, we're still not good on how to put the tick marks, right? So let me show you some mistakes that everybody makes, right? This doesn't work. A tick mark in the middle doesn't mean anything, right? But it's an honest mistake. Doesn't the midpoint mean that this pink thing right here should measure the same as that orange thing right there? Shouldn't those be the same? So what you do is you put a tick mark in the middle of the pink and you tick mark in the middle of the orange, right? You mark those the same. Rock on? So now the part that you don't like, number one, reading, and number two, putting information in a picture. What does that say right there? A capital A next to a capital B, because it doesn't have a segment bar above it. It doesn't have a ray bar above it. It doesn't have a line bar above it. Do you remember? It starts with a D. And it's cool that we don't remember, because it's been over a week since we talked about it. Go ahead. What do you think about distance? Cool. So what I want to do is get better at it, because I know how hard this class is if you can't read it. This says the distance from A to B. We're going to say that together. This says the distance from A to B. It's 52. Let's put that in the picture. The distance from A to B is 52. Go ahead, put it in the picture. If you put it in the wrong spot, we'll fix it. But how do you feel about, boom, right there? It could be below it, too, like above it, below it, but from A to B, right? 52, does that sound all right? Hey, without reading any further, does anybody know the distance from B to C? Shouldn't they be the same, right? And do you know why? Because the definition of midpoint says so, right? We don't need to write that down, but I'm just kind of talking you through some proofs that are coming. Like, why did we put these tick marks on here? Because they told me that was a midpoint. And isn't that what a midpoint means, right? That's like the definition of midpoint. And then what's this say right here? The distance from A to C is 4x plus 4. That's tough to put in the picture. I need you to draw like what I call like the big old honker. You know, it's like the whole thing. I don't care if it's above it or below it, but the whole distance from A to C is 4x plus 4. Like, isn't that the whole thing, right? You cool with how I put that information in the picture? They ask us to solve for x. I do everything in colors. I'm sorry if you're colorblind. Are you cool with this is pink, this is orange, and this is green? Can I write an equation in colors only? Pink minus orange equals green. Pink plus orange equals green. Pink plus pink equals orange. Like, what could I do colors-wise? What has to be true in this situation? Pink plus orange equals green. Are you with me on that? Those put together. So what's pink plus orange? If you want to do that in your calculator, you can. How much? 104. Equals the green one, which is 4x plus 4. But man, a lot of people are going to struggle with that when they're not just numbers like 52 and 52, right? It's pretty obvious. Well, the whole thing's 104. Shouldn't that be 4x plus 4? It's going to be a little weirder on homework. I'll let you solve that for x. Solve that for x. So subtract 10, 82. Bless you. Measure of angle EBF, that's right here. 7y minus 3. Measure of angle FBC. Did you get that in the right place? Are we cool with that? But then they changed the question wording a little bit. They didn't tell me they were perpendicular. They're asking me, what does y need to be to make them perpendicular? But you can still treat it the same way. If they were perpendicular, what would this entire angle measure? 90. So you still add them together and set it equal to 90. So let's try it. 7y and 3y. How many y? 10y. Adding up our constants, -3 and +3, how much does that add up to be? Nothing, right? So you don't need to put it. And that would equal how much? 90. Solve for y. What do you get? So if y was 9, those would be perpendicular to each other. What do you think? Not bad, huh? We've got to do one question on the back, right? So if you'd flip over, there's nothing on the back. You don't need to write any of this down. I'll read it to you. We'll draw what they ask us to draw. So on the back, I'll read this in phases. Can we draw segment MN? Just do that. Draw segment MN. You can make it big because we use that the whole piece of paper. Draw segment MN. Use a straight edge. We're just doing this on the back side as a bonus question. Draw segment MN. Cool. I'll do it with you. MN. Now here's where I know we're getting tired. They say C is supposed to be between points M and N. Time out. C is supposed to be between them. Does it have to be perfectly in the middle? No, because they didn't mention the word midpoint. Are you with me on that? You just got to be between them. So put them anywhere you want. It really doesn't matter as long as it's between there. I would probably not put him right in the middle because it's probably not true since they didn't say it was the midpoint. So I'll just do something like that. Are you cool with it? Like C between there. Right? You help me read this. What does that say right there? Not MC, but the distance from M to C, 3x plus 4. Put that in your picture. The distance from M to C equals 3x plus 4. Distance from C to N is 5x plus 6. Distance from C to N is 5x plus 6. And the distance from M to N is 50. Please go either above or below, I don't care where, and put one of these guys saying that's the entire thing, right? The distance from M to N is 50. And see if you can set up an equation with your table mates. I got a pink one, I got an orange one, and I have a red one. What would have to be true about those? Let me ask you this. Does this equal this? Does this have to equal this? Does 3x plus 4 equal 5x plus 6? Do you have information that says that or not? What word would need to be in there for me to know that those two would be the same? Starts with an M. Midpoint? They didn't tell me that. Right? The pink one and the orange one do not have to be the same. But do you have a third member right here that you could help yourself with? Pink plus orange equal red. Are we okay with that? So let's do pink plus orange. 3x, 5x, 8x. 4 plus 6 is 10, and that's got to add up to be 50. And I'll let you solve that for x. And what I'll do is the human nature. I am really good at algebra. I make mistakes all the time. You are okay-ish at algebra. Like I'm better at it than you, and I make mistakes. So we will make mistakes. I'm going to make a mistake. See if you can find my mistake. That is not right. What did I do wrong? That is a very easy mistake to make, though. I added 10 when I needed to have subtracted 10 from both sides, right? If that happens to you, big deal. We'll fix it, I needed to subtract 10 from both sides. Here's another one that a lot of people don't see very easy. This is wrong as well. What did I do to get 32? I subtracted 8 from both sides instead of dividing by 8. Are you with me on that? So, baby, what I'm trying to tell you is if you make a mistake, that's normal, dude. We're not perfect at this, right? We will make mistakes. Let's fix it. Cool? Let's fix it. Okay, so what I gave you, you guys, we're not done. What I gave you had the practice sheet on it. Cross the whole practice sheet out, the one that said learning intention, just cross it all out. Then there are typos on the other side, which is our homework. Just 7 little questions. We're going to fix some typos and we're going to modify. So we crossed out the old practice, and here's the homework right here. There are some typos. The first typo is on number 2. Like problem 1 is cool, right? There's nothing wrong with it. Problem 2, do you see right here where it says CT, like the distance from C to T? That's wrong. Cross that out and change it to the distance from A to T. I'm on number 2. Cross out the distance from C to T and change it to A to T. Then on number 3, there is a problem. I have the measure of angle nothing right there. I forgot to type 3 letters. So right here on number 3, it's supposed to say measure of angle BIT. On number 3, there is some missing letters right there. Can you please put those? Then I want to fix something. Let's go down to the bottom. Sorry, I got to escape out of this. Give me a second. Let's go down to the bottom. And this is almost the way I wanted the worksheet to turn out. Looks like I don't have it open. Let me get it open. Back here on the bottom, I want to kind of talk you through the first step. I want to add something. So let's do like number 5 together. Are we cool with that? I need you to circle one thing right here. They're giving us this. Are those linear pair or vertical angles? Talk with your table. Circle the correct response. What do you think? Those are vertical angles. Cool. What can I do with them? Should I set them equal to each other or should I add them up to 180? So let's do it. 2x plus 6 equals 8x minus 102. You and your table group solve for x. My option for the first move is to subtract 2x from both sides. You didn't have to do that first. I think that's a good idea. Then I don't get an option anymore. I got to add the 102 to both sides. Like I want the x's on one side and the numbers on the other. So I'm going to add 102 to both sides. Isn't that 108? And then you should divide by 6. And like I said, guys, if you need help with the algebra, you got to let me know. I'll come around and help you. Punch it in for me, if you would. 108 divided by 6 is? Cool with 18? Yeah. Awesome. I'm going to add to these questions. I hope you had enough room. I'm sorry if you didn't. I need to justify this. Why? Why did I set those equal to each other? What kind of angles were they? Vertical angles. Why should they be the same? So we'll justify right here. Boom, boom. Vertical angle theorem. I understand if you can't put it right at the bottom, but squeeze it in there somewhere, wherever you got. I want you to do that on all 3 of them. Justify, justify, justify. You will circle what kind of angles they are, and then justify why you did it. Vertical angles are the same, because the vertical angle theorem says so. Linear pairs add up to be 180 degrees. Let us know if you have any questions. Have a good one.